Hi everyone, for today's lesson, we are going to be doing some examples over the properties of trapezoids. In a previous lesson, we already went through those properties, and this time around, we're going to be applying them. We're going to really need to pay attention to the directions as well as pay attention to tick marks to decide whether or not we are working with a regular old trapezoid or an isosceles trapezoid. Please remember that all of the angles of a quadrilateral add up to 360 degrees. So I'm going to write that at the very top. We are going to be using that property. All angles of a trapezoid or any quadrilateral add to 360 degrees. All right, let's go ahead and get started with our first example. You will need a calculator for this lesson, so if you need to pause to make sure that you have a calculator, that will certainly help as well. In this problem, we are told and want to ask, we are asked to find the measure of angle B and the measure of angle D. And what I remember about trapezoids is that base angles in a regular old trapezoid have no relationship. And I know this is a regular old trapezoid because I can clearly see that the legs are not marked and there's no arc marks indicating that base angles are congruent. So what I do remember is that along the leg angles, these leg angles are supplementary. So I'm going to use that relationship to help me to find angle B and to help me to find angle D. So let's start with angle B. Angle B is going to be supplementary with 70 degrees. So the measure of angle B is going to be equal to 180 minus 70, and that is equal to 110 degrees. And these two angles, they add to equal 180 degrees now. Next, I'm going to find the measure of angle D, and it is supplementary with 150 degrees. So that means that if I go 180 minus 150, that is going to equal 30 degrees. And now these two angles, they are supplementary. Notice that the base angles have absolutely no relationship with them. Let's go on to example number 2. In example number 2, let's go ahead and analyze the picture that's given to us. Notice that we have parallel sides and one pair of sides that are congruent. This tells me that this is an isosceles trapezoid. So I'm going to be working with all of those properties of an isosceles trapezoid. In this particular problem, they tell us that AC, which is a diagonal, is equal to 2z plus 9, and BD, which is the other diagonal, is equal to 4z minus 3. And we know that in an isosceles trapezoid, that the diagonals are congruent to each other. They don't necessarily bisect each other, but the diagonals are congruent. So I'm going to write down that property, that the diagonals are congruent in an isosceles trapezoid. So since they're congruent, the equation that I'm going to set up is 2z plus 9 is equal to 4z minus 3. And we want to simply identify the value of z. So I'm going to subtract 2z from both sides. I'm going to end up with 9 is equal to 2z minus 3. I'm going to add 3 to both sides, and I end up with 12 is equal to 2z. Dividing both sides by 2, we find that z is equal to 6. Let's move on to example number 3. In example number 3, we are asked to find the measure of angle J and the measure of angle K. And once again, notice the tick marks are on the legs and they're congruent, indicating that this is an isosceles trapezoid. So in an isosceles trapezoid, we have base angles that are going to be congruent to each other. And we also have diagonals that are going to be congruent. But in this problem, we don't have any diagonals. What I do want to find is I want to find the measure of angle J and the measure of angle K. So the measure of angle K is actually going to be pretty easy. That is equivalent to the measure of angle L, which is a base angle, and that's 124 degrees. The other thing that I know is that we have consecutive interior angles, and consecutive interior angles are supplementary. So that is in all trapezoids. We will have along the legs, those leg angles are going to be supplementary. They will add to 180. So the measure of angle J is going to be equal to 180 minus 124. And 180 minus 124 is 56 degrees. And that is our answer. Let's go ahead and move on to example number 4. In example number 4, we are told trapezoid EFGH has FH that is equal to 9, and A to E, just this length right here, is 6. We want to find A to G. So this is an isosceles trapezoid. Once again, if you look, we've got these tick marks right on the legs, indicating that this is an isosceles trapezoid. So I'm using those properties of an isosceles trapezoid. And once again, the diagonals are congruent to each other. They don't bisect each other, but they are congruent. So I know that this whole length of E to G has to equal 9. So it's 9 is equal to 6 plus, and I'm just going to call this length right here X. It's equal to 6 plus X. And if I were to subtract 6 on both sides, I would find that X is equal to 3. So therefore, AG is equal to the length of 3. Next, we want to circle. We've been working a lot with isosceles trapezoids, and we want to circle the trapezoids that you can conclude are isosceles. So it's all about using those properties. And letter A, I can clearly see that we have one pair of opposite sides that are congruent. And if we have opposite sides that are congruent, I can say that letter A would have to be an isosceles trapezoid. Letter B has base angles that are congruent. And if you have base angles that are congruent, I can say that letter B is an isosceles trapezoid. Letter C has consecutive sides that are congruent, and consecutive sides are not congruent in an isosceles trapezoid. So letter C is out. And letter D, 6 plus 2 is equal to 8, and 6 plus 2 is equal to 8. The diagonals are congruent to each other. They don't bisect each other, but they are certainly congruent. So therefore, letter D is also an isosceles trapezoid. So all of the ones that we circled, A, B, and D, all of those are isosceles trapezoids because they have those properties of it. Now, letter number 6, we're going to be working with mid-segment. And the mid-segment theorem, once again, is that, I'm going to write that down really quick, the mid-segment length, that is equal to the length of our bases, so base 1 plus base 2 divided by 2. So we are cutting it in half. That is our mid-segment theorem for a trapezoid. So we want to find each length. So in letter A, we want to find the length of KL. And KL, I don't know what that is. So I'm going to call it X. So X is going to be equal to 15 plus 26 divided by 2. So that is my bases added together and then divided by 2. So 15 plus 26, I'm going to put that into my calculator. That equals 41, and 41 divided by 2 is 20.5. So therefore, KL is equal to 20.5 and whatever units that we're talking about. Now we're on the letter B. And in letter B, we want to find the length of PQ. And I'm going to call length of PQ X. So I have 7.5 is equal to X plus 5.5 divided by 2. And what I'm going to do is I'm going to set up a proportion. And what that's going to do is that it's going to allow me to use a thing called cross product. And 2 times 7.5, that's 15, equals x plus 5.5. I'm going to subtract 5.5 on both sides. And when I do that, I end up with 9.5 is equal to x. So therefore, PQ is equal to 9.5. Finally, we have example number 7. And in example number 7, we want to find the value of x. So I'm going to be working with that mid-segment theorem again. So I'm going to write 20 equals 6x plus 28 divided by 2. And I'm going to show you another way. So in the previous problem, I showed you using cross product. This way, what I'm going to do is I'm going to instead multiply both sides by 2. And what that's going to do is it's going to undo the division of 2. So the division of 2 eliminates the multiplication of 2, leaving us with 40 equals 6x plus 28. So in our previous problem, I set up a proportion and did cross product and was able to set up an equation. This one, I decided to multiply both sides by the denominator. Both approaches will get you the exact same answer. You choose which approach you like better. So now I'm going to subtract 28 on both sides. And when I do that, I end up with 40 minus 28, which is 12. So 12 is equal to 6x, and I'm going to divide both sides by 6, and I find that x is equal to 2. And all we needed to do was find what x is. So there's my answer, as well as the end of this lesson. If you have any questions over how to solve these problems using the properties of trapezoids, please feel free to email me. Otherwise, I hope you have a wonderful day.